Hi everybody, welcome to my channel. In this session I am going to explain you the working of Hartley oscillator and its applications, advantages and disadvantages. As we know very well, oscillator means it is going to produce oscillations. That oscillations can be of any shape like sinusoidal, rectangular or triangular. Depending upon the input that we are going to give, we get the output. If the oscillations are continuous, we say that undamped oscillations. If they are going to die out with respect to time, they are considered as damped oscillations. An oscillator majorly requires a tank circuit because of which the oscillations are going to be produced. Let me explain you in detail. So after the completion, the learner will be understanding Hartley oscillator, working of it, and also expression for the frequency of oscillations, the advantages, disadvantages and applications. Majorly, these Hartley oscillators are going to be used as local oscillators in radio and TV receivers. Here the tank circuit consists of one capacitor and two inductors, and these two inductors are coupled inductively just like an auto transformer. This is the circuit diagram of Hartley oscillator. Let me explain this circuit here. This combination L1 C L2, this forms the tank circuit, and whenever the supply is given, VCC is given, the capacitor will be charged, and once it is charged completely, it discharges through the circuit, forming this path C, L1 and L2, and thereby producing the required oscillations to the base circuit of this transistor. And once the transistor amplifies the oscillations, the increased oscillations are going to be given back. So here the output is fed back through this inductor L2, which is coupled inductively to L1. So obviously whatever output we get here, this output will be given as the feedback signal, amplified output. It is given as input to the feedback signal to the input, and this is going to fulfill the losses which occur in this particular tank circuit, thus creating the sustained oscillations. Means the oscillations will not die out with respect to time, as the losses of this tank circuit are going to be completely balanced or supplied. So all these things R1, R2 and RE, just we have discussed in the previous sessions. The purpose of all these things are same. These are going to form the biasing circuit. CE is the emitter capacitor connected across this resistance RE in order to have the smooth flow or to reduce the reactance of this overall path, and C input, it allows only the AC signal and blocks any DC. And RFC, this is radio frequency coil, which is used here, which blocks the AC. And again this capacitor, this is the coupling capacitor or output capacitor, which is connected here, and this blocks any DC signal in the output. This is the brief working of Hartley oscillator. So let me go through in detail here. The different parts we are going to have: amplifier, transistor amplifier, and tank circuit, feedback circuit. Let me go through the construction. So already we have discussed regarding this R1, R2 and RE are the resistors, and C input, C, E, CB and C are the capacitors. RFC is the radio frequency coil, and L1, L2 are the inductive coils. T is the NPN transistor. So here we are using NPN transistor here, and power supply is VCC. So here already we have discussed that the tank circuit is made up of C, L1 and L2. The coil L1 is inductively coupled to L2. The combination function, it works as auto transformer, and whatever resistors we are using here, R1, R2 and RE, these are going to provide the required biasing and stability to the circuit. And capacitor CE bypasses the emitter current. And the output capacitor or the coupling capacitor is going to block any DC component present in the output signal. The radio frequency coil blocks the AC component. The capacitor C input blocks the DC components to the base of the transistor. So all these things are similar to the things that we have seen earlier. And when you go for the working principle operation, when the supply is switched on, the collector current starts increasing and charges the capacitor C, and once the capacitor is fully charged, it discharges through the coils L1 and L2, producing the oscillations of the frequency given by F is equal to 1 by 2 pi root of L1 plus L2 into C, where L1 is the inductance of the first coil, L2 is inductance of the second coil, and C is the capacitance of the tank circuit. And these oscillations across L1 are applied to the base emitter junction and appears in the amplified form in the collector circuit. And as we know well that the coil L2 couples the collector circuit, and this energy will be fed back into the tank circuit by means of the mutual inductance between L1 and L2. So whatever energy which is going to be taken from the collector circuit by L2, that will be given to the input side through the inductive action between the coils L2 and L1. So this energy, whatever energy we are feeding to the input, which it is going to be supplied to the tank circuit to overcome the losses. And one more important point that we need to discuss here is phase shift. As we know, the tank circuit is going to produce a phase shift of 180 degrees here because it is a combination of L and C. And as we know well, the amplifier itself is going to produce a phase shift of 180 degrees. So 180 plus 180, 360 degrees phase shift will be there. And this is actually this condition is to be satisfied, known as Bark-Hasan criterion, one of the conditions of Bark-Hasan criterion. So these conditions are to be satisfied in order to achieve the sustained oscillations. So as you know well, the tank circuit produces 180 degrees of phase shift here, and amplifier further produces 180 degrees of phase shift. Why it produces 180 degrees of phase shift we have discussed in the previous lessons. Please go through that. So hence the total phase shift will be 360 degrees or 0 degrees. So once it is 0 or 360, the energy which is fed back to the tank circuit will be in the same phase with the oscillations. So go for the advantages of Hartley oscillator. It is easy to tune and adaptability to a wide range of frequencies, and it is used as local oscillator in radio and TV receivers. The drawbacks, if you discuss, it requires inductors and transformers are required here, which is a little bit expensive, and the frequency stability will be less, and it is not suitable for generating pure sine waves, as there are more number of nonlinear elements. It is difficult to generate a pure sine wave. And if you go for the applications, it is used as a local oscillator in radio receivers and TV receivers, and also for induction and dielectric heating purposes for high frequency applications. So let me brief you the summary, means the topics that we have discussed till now. The circuit diagram of Hartley oscillator, its analysis, working, frequency of oscillations, advantages, disadvantages and applications. So let me give you some objective type questions here. So the tank circuit of Hartley oscillator produces a phase shift of these are the options we have, and the solution, the answer is 180 degrees C. Similarly, the Hartley oscillators are used in These are the options we are given: digital clocks, function generators, signal generators, and induction and dielectric heating purposes. So the option is D. So Hartley oscillator is commonly used in TV transmitters, radio transmitters, radio receivers, and digital clocks. The option is C. These are the frequently asked questions in the examinations. Draw and explain the working principle of Hartley oscillator, advantages and disadvantages, and also the applications. That's all for today's session. So what my request to all of my viewers is, please do watch my videos, subscribe to them, and give your valuable feedback. Thank you for watching.